Hi everyone, welcome to another Wolfram Language Design Review. This is a few special projects related to version 14.2. All right, dates, times, and tabular columns.
Yes. So yeah, Nick,
We already talked
start with.
about this, the mid-date function, right?
Yep. Yeah, we've talked about it. We basically implement everything we wanted to do with it and just wanted a final pass on the ref page and to talk about the default method, which is something we talked about a little more detail in ILD at one point. So this is in a lot of ways a sister function to min date and max date. Uh, the idea is you give a date and you can get the midpoint of it or the middle day or
Yeah.
the hour that is 2/3 of the way through.
Why is that giving it in that granularity?
It's giving
Well,
an instant by default.
I think that's a mistake.
Well, the question is what would the default granularity be for an arbitrary input? If the input's a month and I inherit the granularity, I'm just going to get the input back. We could
I understand. I understand. So
assume,
I think there's okay. So what does min date do for that? Does it give
yeah,
I
it will
see.
also give the
Well,
first
okay, fair
instant.
enough. Then I guess it has to give that.
Yeah.
What does it do for an odd numbered month? Does it give halfway through the day?
Yep. So if you did it for October, you'd get noon.
You mean I'm supposed to know how many days there are in each month?
This is a convenient way to know information about it.
One of these years I'll know all of them.
I remember to rhyme
No,
when I was.
oh, that's min date.
That's
Min
min,
date.
yeah.
Funny. Okay. Okay.
So the questions I have are the naming convention we've come up with for the method option. Jose and I are pretty happy with, but I wanted to run it by you.
Okay.
Generally, the weighted prefix means we are taking into account granularity and generally the
Oh,
length
there's
of the
space missing
granularity.
there.
Yeah.
Um, so in other words, if there's a whole day,
Yep.
the whole weight of that whole day, right?
Yeah. And so there's examples down in the method section, but the
By the way,
weighted mean, for
centroid is misspelled
example,
there.
oh, that's my bad. Yep. Was editing a couple of
I mean,
things.
are you sure it shouldn't be called granular mean?
We
Isn't that what it
could,
is? In other words, it's the mean given that everything comes in a lump of a day. Isn't that correct?
yeah. So basically, like the with the weighted mean, if you have a week specified, it doesn't matter if that week appears as a sequence of 7 days or appears as a date object that is a week, it's weighted the same. Whereas if
I
you do
think it
something
should be
like
called granular mean.
granular instead,
I mean, what
okay.
do you think? I mean, that seems like it captures the idea better.
Mhm.
That it is a mean where every object is treated at its specified granularity.
Mhm.
We had
Right?
considered weighted, granular weighted or weighted granularity means. It was a bit too long, so we
I
removed
think
from that.
granular mean because I worry about weighted mean because weighted mean suggests that you're putting, oh, Tuesday is more important than Thursday type thing.
I see. I see. We provide our own weights. Yeah. I see.
Yeah.
Yeah, I
Okay.
don't mind emphasizing granular instead. So
hmm
there's no ambiguity with
Okay, so
dates what
what is the difference
granularity.
between centroid and median?
So the difference in that we have here, which I wanted to ask about, is that the centroid is taking into account the exact length of time, where the median is treating the granularities uniformly. So February is weighted the same as March with median currently, and with centroid, they're weighted differently because February is shorter than March. They're both potentially useful. I think the centroid is maybe the better method if we're just going to pick one.
Wait a sec, wait a sec, wait a sec, wait a
What
sec.
what
What's the difference
cent
in mean and centroid? Right? I should have asked. Go ahead.
yeah. No, I'm confused too. So centroid for like in geometry, it's basically like a mean.
Right.
Yes,
So,
and,
but
and the comparison that Nick was making was between centroid and mean.
oh,
Okay,
I
so
thought you said
explain it
median.
again.
It's a spelling mistake there.
Yeah,
Centroid.
I've already commented on the spelling mistake. Yeah.
Oh,
Explain the
So,
difference between
so
centroid
the
and mean
difference
again.
is that in weighted mean, all months are treated equally with the quantity 1 month. In centroid, we do a more precise computation, and we take into account the fact that months are different. It's a centroid
I get it.
region computation.
It's maybe not the best name, but it's the distinction in how I was actually computing the two.
I understand. So one of them, I mean, granular mean suggests it's based on the granularities.
Right.
This thing here is not based on the granularities. It's based on the actual.
Duration. We could call it duration mean, maybe, but
That's not bad. Well, okay, hold on. It's a mean. And how is that different from mean of midpoints? What does that mean?
so that means regardless of the granularity of the dates, we basically look at the midpoint for every input.
You know
and
what we
take
should
the
do? We should
mean.
call that midpoint mean.
Midpoint. We had actually thought about that and weren't sure if it was too
I
wordy.
think that's
but-
absolutely what we should do.
Okay, so midpoint mean and midpoint median both look at the
Right.
midpoints and take the mean or median. Okay.
And then you should say min max mean.
Okay.
Or
I'm all in
bounds
favor
mean or
of
something.
Yeah,
Bounds
we thought
mean,
about
maybe?
bounds mean. I didn't know if it was too obscure, but it's literally the mean of the bounds. So if that makes sense to you, I'd
That's
be
what you
happy.
said in the right-hand side there. So
Yeah, I know.
I think
Yeah.
bounds mean makes sense. So that
Okay.
now leaves, I mean, weighted centroid is kind of mean, isn't it?
yes.
I mean, isn't that
Yep.
basically?
Mhm.
Different weights though. So
Yes, it's like a more precise version.
Well, we could call it weighted mean, for example.
well, he has two of them.
No. Weighted mean is called granular mean now. The
Oh.
weighted mean at the beginning there is granular mean.
Okay. Then we're good.
So I think it's granular mean, granular median, weighted mean, which was weighted centroid, then midpoint mean, blah, blah, blah. Now, what's weighted overlaps?
Weighted overlaps is a weighted mean, but it gives extra weight to the overlapping intervals. So it's sort of
So it's
looking
like
at
centroid. Is it like centroid or is it like?
It is like centroid. It is based on the durations that overlap get additional weighting, sort of looking at
Yeah, I
the
see.
input as a probability if there's a bunch of
Okay,
dates that
I get
cover
it.
one spot.
So the thing weighted mean. Okay. One of them is the total coverage. The other is weighted mean, to me, is really what your weighted overlaps is. So that leaves the weighted mean of the other one is kind of a mean of the covered area. See what I'm
Right.
saying?
Yep. That's yeah.
What would that be? Mean of.
And what about the previous
Now,
proposal?
just think, real soon now, we'll have an LLM that will listen to what we've just been saying, and it will say, what about this? And we'll either say, that's a brilliant idea, or
Yeah. In some ways, it's like an area mean, but we're not really thinking about it spatially, even if.
it's like a coverage mean. It's like
Yeah.
a mean of what is covered. What is that called in math when you have two? It's kind of a zeroth order mean, where you don't take account of ignoring overlaps. How would you say ignoring overlaps? Have we had this issue in other places?
No.
It's like
No,
a
we have
Boolean
one.
function. It's like old Mr. Boole. you know, 1 + 1 = 1 type thing. It kind of feels almost Boolean.
Mhm.
See what I'm saying? Because it really is, it isn't, you don't accumulate, you just, don't we have that in regions, Roger? If you have the overlap, oh, you know what it should be? Union. That's what it should be called.
Hmm.
It should be called something like weighted union mean.
no, but that's exactly what union doesn't do. Do
No,
you know what I mean?
no,
It's
no.
just
It's exactly what union does do. It takes what this is doing is. Oh, I'm sorry. Yes, it's the other way around. The thing we
right.
were calling weighted mean should be called weighted union mean, and this should be called weighted mean.
That's fine.
Yes, I just said it the wrong way around.
Yeah, I think
But
that's
sorry,
sorry. Go ahead.
Or
I'm
even perhaps union mean. I don't know. Weighted union mean or union mean. Go ahead. What are you going to say?
I don't see where union plays a role here. This is the distinction between granularity and duration that we were discussing before. The mean is the same mean in both cases.
No, 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 Jose. I think the point is this: if there's a region of these dates where there's a week that's double covered,
Yes.
in the case of what you're calling weighted overlaps, the double covered region counts for twice.
No, no. In all cases, they count for twice. In overlaps, it counts even more. So Nick has
How
an
does it count
interpretation
even
of
more?
overlaps. So for example, in weighted mean, if you have the same date multiple times, it counts multiple times, like in standard mean.
But what about the overlap? It's the overlap. It's the granular overlap that doesn't count. So it's the union mean in the case where there is a well, maybe I'm confused.
I think
Yeah.
I have problems myself understanding the weighted overlap. So Nick has a formula to weight even more things that have overlap.
Why?
I mean, we had a long discussion with Steven the previous time, and this was what what Nick interpreted. If
Yeah, what we had been talking about, basically looking at the date intervals themselves as uniform distributions, and that we were basically saying these overlapping periods are effectively areas with a higher probability if we're looking at the
Yeah, that's why I'm
inputs.
saying
Yeah.
union, because if you
Mhm.
have union, it's like take all the points and just was there a point there, yes or no,
Mhm.
rather than, stack them up if there were 2 points there.
Yeah, we can absolutely have a method that is a unioned or like a flattened version that just says, regardless of the number of instances that it
That's what I'm saying.
occurs.
But isn't that what centroid is doing?
The version I have had two versions of Centroid. One did exactly that, and talking with Jose, we had moved Centroid in the other direction of saying it will take into account the fact that multiple instances fall over the same duration. It doesn't give extra emphasis beyond the fact that it occurred twice, so it is twice
Well,
effectively
do
in
you
the.
think that one should just be called mean, the weighted centroid thing?
Yeah, I mean, I think that's the direction we've looked at as the most intuitive version of a mean
All right.
is
So
that.
what are we now proposing? There's mean for weighted centroid.
And I think
Then what do we call weighted
union is
overlaps?
potentially. I
What's
think
that?
weighted overlap should probably be kind of set to the side as something that was experimental, and I'm not sure.
Okay, so let's give it up. Right.
Yep. And
Mhm.
then I.
But I mean, we have this notion of a union mean.
Yep.
yes, yes, we can have separate versions of these being unions. That
Okay,
there is a
fine.
union in advance.
Okay,
Mhm.
all right. So the default here is what? Mean? Is mean the default or is granular mean the default?
Granular mean is what we've been using as the default.
I think we should probably go on with that.
Yep. Okay.
Okay. Any more to figure out with this?
Nope. I think that's it for Middate.
Just so I understand.
Mhm.
If I say the middle of the 19th century, let's say, reasonable enough. fine.
Mhm.
Okay. Tabular has dedicated to, what's this?
There's a
So he-
subsection. Yep.
Oh, I didn't even look at this. Oh, gosh.
So here we wanted to present the types that Nick and Rob have been working on for dates. And so there is
Okay.
a date type and a time type. And then there is a date time, which is a special case of date when we have full instant granularity.
Isn't that confusing? I mean, because we're using date
It
has
matches up.
traditionally meant.
It matches up in a great way with the world around us, though.
I agree.
Yeah. Under the hood, date time is the same thing as date. It just has it's restricted to only work for cases that have instant specification, basically.
Reluctantly, I agree. I mean, arguably, date. Well, at this point, we have date object. We have now,
Mhm.
and we have date object, right?
Yes, our date objects contain both coarse granular dates and timestamps.
I understand. And
And
time objects are untethered times, so to speak.
right. Mhm.
Yeah, I guess I don't have a problem with that. I mean, we could move to a world in which, we don't need to call it a date time object. That's silly.
No, no.
Mhm.
And I think it's great that we have the general concept that allows us to have, I don't know, GPS time in which they count weeks and seconds within a week. We
Right.
could implement that, right?
Yeah,
That
okay.
doesn't fit date time at all.
Those are type specifiers, right? So
Mhm.
you're using this
Yep.
inside a type specifier. That's
Yes.
pretty ornate. But I
Yeah,
guess
so
it's okay. This is the world of types.
yes. And the model here is data object itself. So we have to store the parameters of the collection of objects, data objects in input.
And we just have the extra prefix element that is the stored integer type.
So in Tabular internally, the dates are stored as Unix times. That's for efficiency and for efficient computation and for relation with other system libraries like Arrow that you do that too.
Sorry, I got distracted for a second. Could you say that again?
Yeah, so this integer 64 means that internally we are storing dates as Unix times in milliseconds, if I remember
Yeah,
correctly.
for the 64-bit integers, the default's milliseconds.
I mean, look, this raw data object thing is fairly random and grotesque at some level. Because, imagine the future. I doubt that it's going to matter whether it's introduced. I mean, it might matter forever. It might be like railroad gauges or something where it's just set for the rest of time or something. But I don't really think, I mean, this is not really a user level thing, particularly.
Right,
This is a system implementer level thing.
Yeah.
right. This is for the compiler, but the compiler needs to know these things.
Yeah, right. Okay, I think it's fine.
Mhm.
Okay, tabular column. I see, it's deducing the type.
Yep.
Of this.
So we have conveniences of, it looks at the input and determines what the column type should be. It has some heuristics for conforming the dates if
My
they're.
gosh, can it really do that?
It can. We've experimented with different versions of detecting common bits of the date, and we've tried to limit it to if the day is the same for the entire column, you can move
Yeah.
it into the header.
And by the way, I mean, presumably for quantities, we'll be able to do the same thing. Maybe we already can.
Yes.
Mhm.
Can we already do it?
Yes.
Yeah, we move the unit.
That's nice.
Mhm.
It's nice. What's happening here?
So this is just showing that it detects the input parameters and including time zone and calendar, etc., and moves them into the column type. We also re-implemented a lot of the date functionality to be much faster.
Good.
So this is sub-microsecond processing to convert to date strings and from date strings.
What is this?
This is just showing a bunch of different granularity. So the reason the columns are a little tall there is if you scroll to the right, it's moving some of the timestamps where all of those last three columns all fall on the same day, so it moves it up to the header.
I see. So, I mean, if they were the same year, if they were days that were the same year, would it elide the year and then just give the
We'd experimented with that, and you would end up with funky date formats.
I don't think we need to go with that right
yeah,
now.
we also tried eliding the time part if the timestamps are really far apart, and it got to be a little too confusing. So,
Okay. Day is reasonable. I don't
Yep.
think we have to do any more than that for now.
Okay. And these are just some general quality of life improvements that have gone along with.
I'm going to have to run, but you guys will do great. You'll have fun with Astro events. See you in a bit.
Bye.
Thanks, Roger.
Bye.
Let's see. Date interval. Yes, definitely.
Yes, these two fields are demanding improvements in date interval.
Right. And before long, we really have to have these spatial trajectories as a function of time. It's going to be another thing. Just saying.
You
Something
mean
else where
orbits in Astro?
No, I mean there'll be orbits in Astro, but there'll also be, paths of planes on the Earth. And there was
Oh,
another thing
yes.
where that came up recently,
Mhm,
where we
mhm.
needed that. What was it? Something where we really, really needed. Oh gosh, it was something I was reviewing where somebody was trying to invent a thing which was a position as a function of time. And they wanted some weird, funky version of it. I forget what it was. Okay.
Okay.
Updated time object typesetting to conform. Yes, definitely. Can I see it? Can I
Yep.
just try
Yeah.
it?
Yeah. So if you do now, when you do time object, they'll be consistent.
Looks good to me. Why is it not saying ET or whatever it is?
Because your default time zone is still probably -4.
As opposed to what?
If you look at dollar time zone entity, if you set dollar time zone equals dollar time zone entity, it'll show ET.
And what is it defaulting to usually?
It's defaulting to the system time zone, which is an offset from GMT. Or I guess you'll have to do now first, but yeah. So that case is EDT.
It's nice. I'm sorry, what are we
Yeah.
going to default for people in general?
In general, it's a numeric offset from GMT that's read from the system. We've discussed but not moved forward with defaulting it to the name time zones. But that's something we should probably revisit for the next major version. Because the old time zone system is pretty antiquated.
Sorry, I got distracted by
So
something. Could you go ahead?
so there's two hard-coded time zones. There's dollar time zone entity and there's dollar system time zone. They're both read from the operating system. One is an offset from GMT that's just a number, and one is a time zone entity, which is a time zone ID. Dollar time zone has always tracked what is dollar system time zone historically.
We should probably change that.
Yeah, I think we should look at changing it early in a release cycle and make sure that we don't have
Well,
weird
I'm
fallout,
not sure that time zone. Look, I think it has to be dollar time zone. I'm sure people depend on the fact that it's numerical. So I think
Yeah,
we have to be a little bit more careful. I think we need to, for formatting, we need to use time zone entity or something like this.
Yeah, we could have date object default to dollar system or dollar time zone entity if
That's
not
what I think we should
specified.
do.
Okay,
That's what I think we should do.
that's safer
And
because
not
absolute
change
time
dollar
runs into
time zone.
issues.
Right. Okay. Sandra on our live stream comments, if you have date interval and date objects, doesn't make sense because date objects are infinitely thin. I think we've taken account of that, haven't we?
Yeah, I mean, there are date objects that are instants, so they don't have much in the way of weight compared to date objects or date intervals that are expanded. You know,
Right.
a
So in
date
the
object,
case of one of these weighted mean type things,
mhm,
then the instants are not going to account for anything.
right. But if you change the method to be something like midpoint mean, then the instants count exactly the same as the other dates. So
Yes.
the method option gives you flexibility to account for those how you want to.
You know, I'm beginning to recant on this weighted thing because that point about the fact that if there's an instant there.
Yeah, I mean, we talked about having like a baseline minimum weighting, but it'd get a little funky because you either have to have just an assumption that, oh, instants are milliseconds, but we have dates that are finer than millisecond granularity. You know, we have nanosecond dates, or
Yeah.
we have to look at the whole input
But
and
so
say, okay,
granular
what's the
mean takes
Mhm.
the instant, takes a week and an instant, and treats
Mhm.
them with the same weighting, correct?
Midpoint mean does.
Why wouldn't granular mean
mean
do?
granular mean says, okay, one of these has 0 weight because it's just a point, it's an instant, and one of them has a 7-day weight because it's a week long. So we're going to get
I see. Okay, fair
mean
enough.
that is basically in the middle of the week.
It would be nice to see some examples of this. See whether we
Ye-
see when you write the text, see
Mhm.
whether the text actually makes any sense. If it doesn't, we should look at this again.
Yep. Yeah. Jose and I have walked through a lot of it, so I think it's a pretty
Okay,
consistent
Astro
funnel.
event. Dun-dun-dun-dun.
Sorry. Before we move here, I was thinking about the change to name time zones. Couldn't that introduce some ambiguity? For example, if we have a time object, EDT, and we don't know the date, we don't really know which time zone it is, right?
Sorry, so that again, we have an EDT.
So you have this object there, 18, 15, 52
By the way,
EDT.
I'm sorry, I have a very trivial point to make. I
Mhm.
wonder if we should have a little bit more space before the EDT here. Very minor point.
Well, we could talk to design and look at that. Yeah.
Yeah. Okay.
Yeah.
Sorry.
In principle, the time object should probably actually just say ET instead of EDT because it's headless. It's falling back to looking at the
Definitely.
current offset because the underlying time
definitely.
zone there is actually America/New York.
Okay.
And it's looking up that America/New York has properties including what the display name should be in daylight time versus what it should be in standard time. But that is potentially misleading with a time object being headless, that they all just fall back to what the current time is.
Right, which might not be the case.
Mm-hmm.
Okay. Astro.
Sorry, have you resolved what I just mentioned? I'm worried that by changing to name time zones, we might
We're
introduce
not going
kind
to
of.
change in this
Oh,
version.
okay.
Yeah,
Okay.
definitely not for this version. I think for the next version, it would be worth looking at having the not including like EDT, EST, but instead saying ET for Eastern time.
Yeah, I think that's what we should do. But I think
Okay.
it requires thought. It's subtle.
Okay.
Yeah.
And
Okay.
definitely not for this version.
Okay.
Okay.
Yes. So in the previous version, we introduced the function Astro rise set, which was like the first function
I
that
remember.
was computing events. So now this is a function that computes lots of things, perhaps too much, and but it's a convenient way of centralize syntax and capabilities.
Okay, when can I compute when Venus is going to be full and when the phase of Venus will be whatever?
Well, Phases we don't have yet, but it's one of the things that certainly we can compute. I mean, we will be able to compute.
Okay.
The main motivation for this function was equinoxes and solstices, which people keep talking about, and I really want to have a function that computes them. And
Okay.
then we have the moon phases. So that could be certainly generalized to planet phases,
Yeah.
but these compute phases. And then sunrise and set, which we have in other functions. And then further down, we have many more things.
Okay. By the way, here, why isn't this called the vernal equinox and the autumnal equinox?
Yes, so this is something we wanted to ask you. So the problem is that those are Northern Hemisphere names.
Oh gosh.
And so if you
Oh
go to the
no.
Southern Hemisphere, they change names.
Oh no.
So we have been looking how this is done. And for example, the Wikipedia has these names now, the March equinox, the June solstice, etc., to avoid the confusion.
Yeah. Well, I mean, frankly, vernal and autumnal are a little bit away from uh um a little bit away from just spring and fall. But
Yes, but they are 6 months apart in the Southern Hemisphere.
no, I understand.
So I mean, they're switched with respect to the
By the
Northern
way,
Hemisphere.
Sander comments he never remembers the name time zones and prefers GMT minus whatever. The I have to say, I still have not gotten European time zones straight because I haven't lived in Europe since, I mean, I don't know. They must have had time zones when 45 years ago or whatever, but I don't remember it. I mean, I do know that occasionally the times were different in different places, but it was so rare to make phone calls between countries in those days that I guess it didn't matter. Um, anyway, I'm just observing. Yeah, I think it's one of these things which you never know the time zones of a place you don't live in. Anyway, no matter. Now I'm actually curious. There's Central European time, I know, and I don't know what else there is in Europe. Maybe we could look it up, but whatever. Do you guys know?
I don't know.
Fascinating. Okay.
Spain also uses Central European time, which is horrible, but
Why?
because we are
It's poking
because
out
we are
onto
south of
onto the
England.
west.
The
Yes.
meridian of London goes through Barcelona. Spain is all
Oh
to the
gosh.
west.
Okay, but the UK does not use Central European time. It's off by an hour usually.
Exactly. What I'm saying is that Spain should follow the British time, not the Central
Yeah, well,
European
that's
time.
what they get for being in the EU or something like that. It's probably an EU standard. Is there an EU standard? I don't know.
No, this is something. It's a funny story. Spain was in British time until the 40s, 1940s, but Franco changed it to be in the same time zone as Germany.
Mm,
Like,
mm.
like he must have had some phone call confused with Germany. He said, "Let's change it."
That's bad. The,
Yeah, and we never changed it back.
that's even worse. Anyway, um, okay.
Okay, so now we can compute all these configurations, conjunctions, oppositions, quadratures. So these are things that appear in all these maps.
For some reason, this picture looks like a not very us picture, but maybe it hasn't gone through graphic design.
It hasn't. Yeah, we just created.
Okay.
So you see how these configurations can be computed. So there is a general syntax for event, which is the name of the event and the bodies involved. And then there is a more general syntax, which is kind of an optimization problem, which is like distance problems, separation problems, phase problems, as you were saying.
Okay. So let me just try something here. I
Yep.
want to know if how do I find the minimum distance between the Earth and Mars and when it is?
Yes. So that would be find Astro event
Mhm.
of distance and then Mars, Earth, local minima, for example, local minimum. This is going to find the next local minimum of the distance. And if you, now you may have to download data. Yeah. If you add a date interval in the second argument, it will give you all local minima in that period. So do date interval of,
Can I just do a list here or not?
date interval of list 2024 to 2034, something like that. Yeah, another list, exactly. Yep. Yes, okay. It needs another file for the second half of the century.
Oh. By the way, somebody was telling me about ephemerides.
Mhm.
They said they were doing some pulsar timing array thingy, and they found that one of the ephemerides produced by NASA for one mission got the barycenter of the solar system wrong by a few meters. But they didn't care because they didn't really care where the barycenter was. But apparently, so let's see, what is
Well, a few meters is pretty good.
Yeah, right. Huh. Wow, interesting. Well, those are the times. Let's see, when do they get to? Okay,
There are some.
when is there going to be a you can take bets on when's there going to be a manned mission to Mars? Is it going to make it in? Yeah, right. Which of these is going to make it in? Because these are the opportunities, right? I think. I mean, I think that any other time.
Actually, well, you have to be careful because you want to launch before that event, right? You want to make sure that Mars
Obviously, right.
Yeah.
Right. Yeah, you're right. You're right. So it's more complicated because this is the speed of light. This is presumably distance. I mean, well, it does matter. By the time you're at the second, it matters. I have no idea what frame this is in. What frame is this in?
It's the Earth. So if you compute in astro distance, it would be the distance from Mars as observed from the Earth.
Because the Earth is the second argument, or what?
Yes, it's the second, yes.
So I see, as observed from Earth. So that
exactly.
is when the light signal from Mars reaches Earth, when that light distance is minimum. When that distance is minimum, is that right?
Yes.
For the light travel time, when the distance, the proper time or something. Yeah, well, we got to say all those things. But now I'm curious. I don't know how often this happens. What happens if you're launching? Now you see, I'm going to learn. What happens with Venus? Boy, that was nice and fast.
Yeah, once you have the data, this is very fast.
Huh.
So these times are typically, there is this formula, 1 over the period of one orbit minus 1 over the period of the other orbit to get these states.
Is that obvious?
Well, it requires some algebra.
Should we be loading the ephemerides for the moons at the same time as Jupiter itself, or does it not matter?
Well, the thing is that for astrographics maps, you want all the bodies at the same time. So that's why this is segmented.
There's an extra line of space here. Seems like a minor, very minor issue, but might as well report it. Huh. What do you know? That's not obvious to me. Oh, it's because the Earth is the one that matters most, and it's like a parallel resistor.
Exactly. The fact that Jupiter is getting slower, this 1 over the period, yeah.
So it's like the same formula as the formula for resistance of parallel resistors. Is that right?
I see. Yep.
Which I don't fully understand why it would be the same, but that's kind of amusing. Okay. All right. So
So I think there, if you want to see funny examples, there are in the other page. Here I just got it. For example, this was an event that made it into the news in 2020 because Jupiter and Mars got in a conjunction. So that means the same exact ecliptic longitude.
Right.
So you see in the map below, which is in ecliptic coordinates, they are vertically, one on top of the other. And they were so close that you could actually see their moons at the distance they were. Really close, like
What do you
0.1
mean?
degrees. So you see all the moons around them?
Yeah.
They were really close in space.
What were really close in space? I don't understand.
So that's Saturn, you're pointing out, and that's Jupiter.
He's
Yes.
just mentioning that if you looked at it in a telescope, you'd have been able to see both the planets and their moons all in one
I
view.
see at the same time.
At
Yeah.
the same time,
The
exactly.
telescope plate, you would have seen this particular thing.
Exactly. And you see, this is 5 arc minutes with the grid lines of 1 arc minute. So they were really close.
Wow. Okay. Yeah, it's kind of like, interplanetary air traffic control or something. Could these planets, except that it's just projected,
Mhm.
it's not like they were actually, if their orbits were much more complicated, then they could actually have,
Right.
that's presumably what happened in the early solar system, is that they were more complicated and they occasionally crashed into each other, as opposed to just being projected the same place. Okay, distant Earth, Moon, equal to 400 kilometers. That's
So
cool.
this is a bit similar to the implicit entity language, which we say equal to a value, and you get all the instants in which the distance from the Earth to the Moon was exactly 400,000 kilometers. And then there is a version in which you say further down greater than, and then it reports the
very cool.
date intervals in which the distance was greater than 400,000 kilometers.
So there's a lot of spelling errors here. Extended is wrong. Adjust here. What is the adjustment?
The adjustment means, and this is something that unfortunately doesn't work yet, you can say, give me the date interval in which the distance from the Earth to the Moon is the absolute maximum except for 100 kilometers. So 100 kilometers less than the maximum to the maximum. And you get the date in which the
I
distance
see, the
was.
interval, right. So if I wanted
Exactly.
to know if I could launch to Mars, so long as it isn't more than, so long as it's within 90%
Exactly.
of the closest approach.
Exactly. So it's a way of adding a little bit of error to the condition of margin, if you want. And then it converts the date results into date interval results.
Yep. Well, this is cool.
It can do many things. And an advantage of having this type of notation rather than separate functions is that, for example, the periapsis, which is named in many ways, we can now support perigee and perihelion.
Sure. Right. So if I say, can I do that?
The
Find
perigee doesn't work yet, but you can do the distance local minimum. It's the same thing.
Okay. So I've just got to do this. The one
Mhm.
obvious thing. You know what I'm going to do. Maybe you don't know. The distance from Mercury.
Yes, you have to select.
By the way, different topic, but we should change the formatting of these things. They really look terrible. This thing here looks terrible. Can we bring that up in a LCC meeting, please?
Yeah.
If you want to see all of them, do date interval of that.
Why
So-
wouldn't that give me all of them?
Because we interpret that a date object always means the beginning of that date object.
I don't think that's right.
The date interval.
I don't think we should do that.
Well, it's a rule we have in nearly everywhere, which is date objects represent single things and date intervals represent multiple things, extended period. But we we could declare that everything of granularity greater than something means the extended period.
I think that would be sensible. Just want to see how this works. This is exciting. I've never seen this in real life. What the heck happened there?
Is that
I
outlier?
don't know. I would have to, that looks very suspicious.
So the advance of the perihelion of Mercury, where would we see that here?
I would have to think. I think the information is here, but
So
I
do
would have to
yeah.
think how to extract it. It's a good question.
But what the heck is that?
Yes, I don't know. I suspect something. It may be a sampling
I'm going
issue.
to guess. No. I'm gonna guess. I'm gonna guess that's when Venus was close to the time when it was at its. Let's just find out. Let's just find out. How would we find that out? We would want to know position. What is it? Min position?
Well, perhaps you want the closest, the absolute minimum distance between Mercury and Venus or something like that.
Yeah, right. But let's. But I just want to find what that date was. Oh, that was 344th element. So this was 344th element of this, give or take. Okay, 1883. Let's find out what the distance is between. So I'm just going to plot astro distance
Mhm.
of Mercury. You know, in a perfect world, this is a luxury item because it's almost never come up. That control equals would look at its context, something to bring up in user assistance.
I see.
I should bring that up. We've never thought about that. Mercury to Venus. And then what we want is over the period, let's say.
The dated of Venus.
Here.
Yes.
Okay. So let's say from 1875.
No, do year. Just put a year there and do a plot of year goes from the symbol year. No, the symbol.
Oh, I see. Y or something.
Exactly. Yep.
Okay.
And
And
do
then
plot.
just say plot that Y goes from 1870 to 1890, let's say. What is going on? Well, let's plot the distance between Mercury and the Sun right around 1883.
Mm-hmm.
Of course, this is just sampling at individual years, right? So 1870, that's exactly what they'd be.
Oh,
What,
I see.
January 1st of
So
1870?
let's.
No.
It's
These
not.
are real.
It's a plot.
This
It's a plot.
is a real. Yes. So dated is prepared to receive Gregorian years.
What did this do? There was a bug. There's an error there. What is that?
Does it say which function is complaining? First.
No.
No idea.
Well, it's a bug.
Yep.
Of some
We
kind.
reported.
Okay, so let's try 1880 to 1881.
Mm.
That doesn't look very promising.
Nope.
I mean,
It may be some sampling problem in the function above, in the computation above. That is a sampling problem. Yeah.
That's definitely a sampling problem.
Mhm.
Well, okay. Mercury has either been knocked out of its orbit or we have a sampling problem. I think it's more likely it's a sampling problem.
Yeah, yeah. I will investigate. I haven't seen
Okay.
this before.
But we can make a nice example from the advance of the perihelion,
Mm-hmm.
presumably, if we could even figure out how that works.
Mm-hmm.
That's incredibly cool that we can do things like this.
Mm-hmm. And for example, if you go to the something I really liked is a table that
But I'm sorry.
Yeah, yeah.
I just had a naive question here. What the heck is this weird thing? Same bug there. Okay.
I don't know, something in the prototype.
Well, I am officially confused. And I don't know why that's so different from this. The point, I
Venus?
guess, is that the advance of the perihelion is the fact that the Runge lens vector is not conserved, right? Because it's not an exact inverse square law force. So it really more has to do with when does the, so let me ask this question. When is the, that will be relative to the, there's a precession of the orbit, but maybe that's not relevant to when,
Well,
maybe this is a different thing. Go ahead.
so I think one first has to extract the influences on some planets on another, and that can be computed. And then when you compute all those things, you realize that the orbit is precessing a little bit more than you expected it. And that's because the gravity law is not exactly 1 over r squared. It's the complicated formula coming from general relativity.
Yeah, right.
But if we look at the precession, most of it will be not the relativistic effect, but the effect from other planets will be a larger thing.
Which
But
you're saying, go ahead, what you're saying.
I was going to say that perhaps it's something that these can compute, like find
I
way.
gather when originally people, when general relativity accounted for the advance of the perihelion,
Mhm.
nobody cared because they thought there were so many mushy effects of, the flattening of the sun and who knows what else. So it wasn't a dramatic, story of success of general relativity. See, I pay attention to things like this because we're in the biz of trying to figure out, experiments that probe the structure of space-time. So we should know the historical antecedents.
Mhm.
Um,
But I think the famous 11 seconds were known to be there, and people had predicted that perhaps there was an inner planet that was
yeah, I know.
making
Yeah,
that.
right. It was the dark matter of its time.
Exactly. Yes. Yes. Exactly.
The okay. What else should we look at here? It's wonderful.
So let's go to the application examples. And yes, I just want to show a table that I think is quite nice. Just this first example. So find simultaneously all the equinoxes and solstices during a period of the 20s, and we get this table, which is a table I always wanted to produce because people keep talking about these dates.
It is nice.
And we can produce them with high precision.
Right. Yeah, the people who built Stonehenge would have found this useful, no doubt. But nowadays it would have been built with bulldozers and things. Anyway, never mind. At least if it's even true that it's lined up for the solstice and so on. I don't even know if it's true.
Well, in the calendar, yes, that motivated a nice example also in the calendar type part, comparing the Julian calendar and the Gregorian calendar
Oh yeah.
in the options here, because you can see the jump
Where is this? What?
in the options section above, in the calendar type. Yeah, exactly. So the final example.
It only drifted that far.
Yes, about
21 days.
10
That's
days.
10 days because that's the number of leap of centuries that didn't have the right leap, the right, you know,
Mhm.
what is it, every 100 years or every 400 years?
It's off by 3 days every 400 years.
Exactly.
Right, because the rule is you don't have a leap year on the hundreds. Is that right?
Yep, unless it's a 400.
Right. I see. It was only 10 days. I thought it like gotten to the point where Christmas was in the summer or something.
No. They removed just 10 days. From the 4th of October, they jumped to the 15th of October.
Were people upset about that?
Yes,
Or
they
nobody?
thought they had been robbed of time in their lives.
Yes.
That was a famous complaint there.
That's cool. Okay, let me just look. Well, it's lovely.
So now
Sandra's
Tabular is
asking,
great.
what's that?
Tabular is great to now report lots of dates because they get nicely formatted and
Right.
organized.
Sandra is asking whether we can generate these times, quotes, ignoring the speed of light. I think that is fraught with difficulty.
In astroposition, there is a parameter called light time, which by default is observation, which takes into account the speed of light. If you change it to geometric, then it's like infinite speed
Oh,
light
really?
time. Yep.
For astro position or
For
astro.
astroposition. Yes.
So
Or
does that, so can you set that for this as well?
Not here. In astrographics, it can also be done. It's a parameter of the astro reference frame. So
I understand, but what in this case here, knowing the time of the conjunction or something, I think is meaningless if you don't have this, right? What does it even mean? The time of the conjunction.
it's the time of the conjunction as observed from the Earth, say, right? And
Yes.
so in this process of observation is when you have to take into account the speed of light.
But why not in knowing when the objects are nearby? I mean, what does it even mean? What is the time?
Well, I mean, if the light from, I don't know, Saturn takes 15 minutes or so to arrive at Earth, then not taking into account the speed of light would make errors of that order of magnitude. For the moon, it will be 1 second.
Yes.
But the geometry is the same. It's just that you don't have to correct for the speed of light at the end.
Well, so you're claiming, I mean, there exists a minimum distance. And the question is in what reference frame you report the time at which that minimum distance is achieved. I'm a little bit confused because even knowing the minimum distance, you've got two astro positions of the two objects. I don't understand how you get the distance between them. Go ahead.
The distance is always computed between an orbit and an observer. And so what you do is you do first compute the distance to some point of the observer. And then you correct it little by little until it matches the time at which the light was emitted and the distance that is traversing. So there is a fixed point computation here. a convergence computation. Typically in like 3 iterations, it matches to microseconds.
Wait a minute. What is that again? Say that
So
again.
yes, so you want to compute for example, to see where Jupiter is.
Mm-hmm.
So you first do a computation of assuming the same instant on Earth.
Oh,
And
I get what you're saying. I get what you're saying. You say you don't know. You know where Jupiter is in Jupiter's local time, so to speak, on Jupiter.
yes,
But if
exactly.
you want to know where it is at a particular time on Earth,
Mhm.
the difference between its time where it is and Earth's time depends on how far it is away, and so you have to
Exactly.
iterate.
Exactly. Yep. So that iteration is everywhere in the Astro computations. And one can eliminate it by switching that parameter in Astro position and Astro reference frame. But I haven't propagated it yet here.
And that would then mean, what does that mean in terms of the reference frame? That
The
means
reference
there's a
frame is
simultaneity surface. What?
the reference frame is the same. It's the speed of light, it's infinity, and then the cones are kind of more and more open.
Yeah, I get it. I get it. I mean, the simultaneity surface is the same, but the light cone is just completely splayed open if it's infinite speed.
It-
The
it-
light
it-
cone lives on the simultaneity surface then, rather than being a cone that is that right?
yeah, so when we picture the cones at 45 degrees, it's because we are putting the same units in both
Sure.
axes.
Right.
But if we do the units that we find more reasonable, then the cones are super, super open. And there is only a very, very thin slice around the x-axis that we don't
Yeah.
access in those cones. So by moving to infinite speed of light, we close completely that
Yeah,
thin
I get
slice.
it. Yep. All right. Anything else we should look at here?
No, I mean, you are okay with having all these different computations in the same function? I think that's my
I think
main
we
question.
should do that. I mean, I think and we'll probably want even more of them.
Yes, exactly. There will be more here. Yep,
Yeah, we do not want to have a separate inferior conjunction, whatever computation.
exactly. Yeah, it's way too many possibilities.
Right. That's cool. I mean, we should make sure we have syzygy as a keyword here and all that.
Yep, yeah. Yeah, there's lots of the section of keywords is super long here.
Okay. Oh, we should put appulse in the in Equilux in the spelling dictionary, obviously.
Yes. Yes, that's another funny discussion, the difference between equinox and equilux. So
The longest day versus the equal day versus equal night.
equilux is day equals night, both equal to 12 hours.
Oh, I see.
Equinox is an astronomical consideration. And people believe it's the same thing, but it's not. The equilux can be, it depends on the position. It can be very far from the 21st of March, for example.
Wait a minute. So what is the equinox then?
The equinox is when the sun crosses the equators of the Earth, or in other words, when the ecliptic longitude has a value of multiple of 90 degrees.
Does that mean that at
I
when is
have an
the
example.
sun up vertically in the sky at noon? Is that relevant to this, or is that irrelevant?
It is relevant for the equinox. So
Okay.
if you go to the conjunction, rise, set, culmination, and equilux events. Yeah, that second section. And see the last example, the one for San Jose. San Jose de Costa Rica.
Which is fairly near the equator.
Exactly.
Does that not matter?
Yeah, a few degrees. No, this separation is actually most relevant close to the equator. But the important thing is that the day in which both day and night have duration around 12 hours is 7th of March. It's very far from the 21st of March, which is the equinox.
I see, because it's on the equator, the effect is larger because usually day and night are closer in length.
Exactly. So here, the effect, for example, the mere fact that we count the day, starting the day when the upper part of the sun goes up, that introduces an asymmetry.
I see.
And so it's super sensitive to how do you define day and night and things like that.
Well, this is very cool. All right. And I could play around with equiluxes on Mars and all that kind of stuff, right? And if I
Yep.
did this, it's just crazy that we can do this, but I need to go in a second here. Let's just try this. We have to try it. It's the only place I know. It's like people who hear about the US and they only know New York.
So this by default reports a day. If you compute it now, sunrise, sunset, etc., it will give half of the duration of the
Why
day.
the heck is that so close to the one on Earth?
Mm.
Is that just coincidence?
I don't know. It might be. I mean,
Give me
we
another
can,
solar system feature. One on Venus, perhaps.
well, you can do geoposition 10, 10, 0 for comma Venus. The string also works. Oh, I'm surprised that didn't work.
Let's try it on Mars. Maybe it doesn't like Venus. Yeah.
Perhaps.
Let's just try this.
Try another planet. So this is very dependent on position. And the closer you get to the equator, more and more.
Wow.
Say this isn't another issue with Venus rotating backwards causing problems, is it?
It might be. There might
That
be
might
some,
not converge because it's rotating backwards.
there might be some assumption somewhere. Yeah. Good point, Jeff.
Okay, this is very cool. All right, I should go.
Okay.
Excellent stuff. Talk to you all soon.
Thank you.
See ya.
Bye.
Bye.
Thanks all.